All right, the first thing that we want to do with U-substitution is U-sub is, number one, identify your U. Which is something on the inside. So it could be the inside of parentheses, it could be the inside of an exponent, the inside of a radical, the inside of a denominator, but whatever it is, it's inside of something. So number two is take the derivative of both sides. Which this will all theoretically make sense when I show you an example. Solve for dx. Clean up. Substitute. And clean up again. Okay. And then we're going to integrate. We're going to clean up again. There's a lot of cleaning in this. And then we're going to back substitute. Okay, so that is what we are going to do. If you want to take a picture of this, there you go. Okay, so our first example is the integral of negative 8x squared times x to the 9th plus 4 to the 9th dx. Okay, so here's the issue. I cannot integrate this term by term like we were doing earlier. So before I could just integrate, increase my exponent by 1 and divide by my new exponent. But this time, if I'm going to expand x to the 9th plus 4 to the 9th power, that's going to be huge and it's going to take me forever to do. And then I would have to distribute this through. So that's not an option. Since term by term is not an option, we're going to use U-substitution. So our first step is identify your U. So what's on the inside? On the inside is an x to the 9th plus 4. And then we're going to take the derivative of both sides. So the derivative of U is 1 du. Sorry about my dog. And then the derivative of x to the 9th is 9x to the 8th. The derivative of 4 is 0. And then I took the derivative of x, so we put a dx on there. The next step that we do is we divide both sides by 9x to the 8th because we want to solve for dx. So what this is a 1 over 9x to the 8th du equals dx. So what do we do next? We start substituting. I have a negative, that's going to come along for the ride. I have an x to the 8th. I look over here. I don't have just a plain old x to the 8th. And so that's going to stay as an x to the 8th. This is u. So I have a u to the 9th. And then dx is 1 over 9x to the 8th du. So we're trying to get everything in terms of u. So what's something I can clean up? I've got an x to the 8th here, and I've got an x to the 8th here. That leaves me with a 1/9 and a negative. So I've got a negative 1/9 u to the 9th du. So if we started with this, we know how to integrate that. The integral of that is negative 1/9 u to the 10th over 10. So increase your exponent by 1, divide by your new exponent, plus c. and then clean it up. So we've got a 1 over 90 u to the 10th plus c. But we started with x's, so we want to end with x's. So do we know what u is? Come back up here. U is x to the 9th plus 4. So I have a negative 1/90th x to the 9th plus 4 raised to the 10th power plus big C. So what we've done is we've undone chain rule. So if you'll remember with chain rule, we always multiplied by the derivative of the inside. That's why this part is going away, because we're multiplying by the derivative of the inside. Or because we did. All right, next we have 18x plus 7. And then times e to the negative 9x squared plus 7x plus 5 dx. So that is what we are starting with. Well, this time I've got two insides, so I need to choose which one I want. Well, this one, if I take the derivative, I get this one. So I'm kind of leaning towards this being my u, and I bet this somehow is going to be my du, somehow. So my u is going to be negative 9x squared plus 7x plus 5. Take the derivative of both sides, and we get negative 18x plus 7 dx. Then we're going to solve for dx, which means we're going to divide both sides by negative 18x plus 7. Negative 18x plus 7. So I have 1 over, whoops, hang on, negative 18x plus 7 du equals dx. Okay, so we're going to start substituting in. I do not have a plain 18x plus 7 over here. I've got it multiplied by dx, I've got it divided, I've got all that mess, but I just don't have an 18x plus 7. So 18x plus 7 is going to come along for the ride. I have an e to the u, so e to the u, and then I've got a dx. Well, I happen to know what dx is. Dx is this stuff right here. So substituting that in, I get 1 over negative 18x plus 7 du. So what can I start reducing? This reduces with this. Watch your negative because it's still there. So now I have a negative e to the u du. I know how to integrate that. The derivative of e to the u du is e to the u. So the integral of e to the u du is e to the u. So this negative comes along for the ride, and I have e to the u plus c. And I'm going to pause for just a second. If I have e to the x, its derivative is e to the x. Okay, so if I've got e to the u, its derivative would be e to the u, which means if I come back up and integrate it, I would get e to the x back. In this case, e to the u back. It's just a different variable. Okay, so I started in x world, I better end in x world. So I have negative e to the negative 9x squared plus 7x plus 5 plus big C. Okay, so we want to do another one. We have 5 over 3x plus 12. Dx. So what's my u? Where's your variable? It's in the denominator. So my u is going to be 3x plus 12. My du is going to be 3dx. I'm going to divide both sides by 3. So that gives me 1/3 du equals dx. Okay, this 5 is in my way, so I'm going to pull it out front as a constant multiple. So I've got 5 times 1 over u, and then my dx turned into a 1/3 du. Okay, what is 5 times a third? 5 times a third is 5/3. 1 over u du. So 5/3 is going to come along for the ride. And then we did this the other day. If the derivative of the bottom is in the top, then the answer to the integral is the natural log of the bottom in absolute values. So the derivative of u is 1 du. So if the derivative of the bottom is in the top, then the answer to the integral is the natural log of u plus c. Okay? So what do I have now? Instead of u's, I need to put this back in terms of x's. So I have 5/3 times the natural log of, instead of u, we're going to use 3x plus 12. Plus big C, and those are absolute values. Okay? So we have x squared over the square root of x minus 5 dx. And this one's a little bit different. So we've got an x up here, and we've got x's down here, and you're told that your u is x minus 5. So we're going to be doing what's called exchanging variables. There's just like 1 or 2 more steps, so we've got to add into it because this x squared is here. So let's start off like we normally do. We identified our u because we were told it was x minus 5. So my du is going to be 1 dx. So there's no solving to do there. Just wherever there's a dx, I'm going to put a du. So that's going to be du. Now, the interesting part is when I start with my substitution, I've got this x squared sitting here. Well, there's not an x squared over here, but there is an x. So if I add 5 to both sides, I'll get u plus 5 is x. So now I know what x is. So I can come back over here. Instead of just x, I've got an x squared. So u plus 5 squared. That's my x. Squared. Dx becomes du. And then I have u to the 1/2 power. So everything's in terms of u now. Well, now I got some algebra to do. So u plus 5 times u plus 5 turns into u squared plus 10u plus 25 over u to the 1/2 du. So I just FOILed this. U plus 5 times u plus 5. This denominator belongs to all 3 terms in the numerator. So we're going to use some arithmetic. And we're going to simplify this down. So u squared over u to the 1/2 is going to become u to the 1/2. No, it's not. 4/2 minus 1/2 is 3/2. Sorry. So I get u to the 3/2. 4/2 minus 1/2 is 3/2. Plus 10u to the 1/2 plus 25u to the negative 1/2 du. So u to the first over u to the 1/2. 1 minus a half is a half. And then 25 over u to the 1/2. I just brought it up top with a negative exponent. And now I can integrate term by term. So the integral of u to the 3/2 becomes u to the 5/2 over 5/2 plus 10 u to the 3/2 over 3/2 plus 25 u to the negative, or u to the positive 1/2 over 1/2 plus big C. And now I clean it up a little bit. So 1, that's a 1, divided by 5/2 is 2/5. U to the 5/2 plus 10 divided by 3/2 is 10 times 2/3. So I get 20/3 u to the 3/2 plus 25 divided by a half is 25 times 2 plus big C. So I've cleaned it up, and my last step is to substitute back into x's. So u is x minus 5. Wherever there's a u, we're going to put x minus 5. So 2/5 x minus 5 to the 5/2 power plus 20/3 x minus 5 to the 3/2 power plus 50 x minus 5 to the 1/2 power plus big C. And that is good for this video.